Hi there. Today we're looking at Venn diagrams, which are a great way to organise information in such a way as to help solve problems. There's a little bit of terminology, well, not terminology so much as notation that we have to get used to in terms of how we describe these things. This will help you both in answering questions, because they're used in the questions asked, but also in interpreting the guidance given to you in the formula booklet that you can take into the exam. Now there's a whole load of zones within here. There's just 4 zones actually. There's the not in A or B, there's the just in B, there's the in B and A, and there's the just in A. But there are many ways that we could consider this just using some very simple terminology. So the first one I'm going to say is, if you had the probability of A, that would be everything in there. If you wanted the probability of A intersection B, that would look like that. Now that would mean this bit here in the middle. But sometimes you might want A, so that would be A and B, which we normally get by, in terms of probability, by timesing the probability of B by the probability of A. So that would be A and B. There's another one that looks very similar, and it's very important to remember the difference between them, and that's A union B. Now the union is what tells us. Union means everything together. So this is all of A, including that bit in the middle, and all of B, otherwise known as A or B. If you know the probability of getting A, or the probability of getting B, or the probability of getting them both together, only then that you would add them together to get their total probability. But there are also some others, such as the probability of not A. And that little dash up there means not whatever you've got going on. So that would be everything apart from A. I'm going to lay a whole load of them out for you now to have a little go at working out what you think they might be. Okay, here's 6 different regions for you to have a go at identifying. So pause the video and copy them down and see what you think. Right, so it starts off simply enough with the probability of B. That would mean that we were looking for anything that's in there, in B, and that's it. The next one is a probability not in B. So it's the opposite of that, anything that's not B. So B is going to be left all on its own, and the rest of it is what we're interested in. Then comes to one getting a little bit more interesting. The not is outside. So it's saying we've got A union B, but we don't want that. Well, we talked about A union B before. That's all of A and B. So it's not that. So it's the stuff that isn't that. So we're colouring in everything round the outside of there. Now, curiously enough, there's going to be another one on here which does the same thing. But one at a time. Let's go to the blue one next. So this means not A, intersection in B. So it's got to be in B, but it's got to not be in A. So not at A is all of that around the outside, including this bit here, which is also B. So that's the intersection of not A, but yes, being in B. Subtly different from the union of A and not B. So the union of A means everything that's in A. But also, and that I know has included a bit that's in B, but that's because it's the union, it's taking everything that does that, but also everything that's not B. So it's also including all of this stuff around here. So the bit that it isn't is just the bit that's only B. Now the last one is not A, intersection with not B. So that means it has to satisfy both of them, not or. So this is satisfying A or that, which is why we got all of this. Not A is everything round there, isn't it? Not B is everything round there. So they're both knocking out anything that is in A or anything that is in B. So it's not A and B, it's the stuff all the way around the outside, which is just like the one in the red Venn diagram just above. Alright, so that's thinking about the notation and some of the things that we might have coming along. Let's see some actual questions to do with probability and Venn diagrams. Here's our first example. Take your time, draw a Venn diagram, give it a go. Right, so take your time. We've got people in the choir and we've got people in the band. Now very often the last piece of information is the first piece to put in. We know that all the people inside the class, so the class is in what we call the universal set, the rectangle around the outside. All the numbers in there are going to have to add up to 30. There are 7 in the choir. That means the numbers in the choir have got to add up to 7. That does not mean putting a 7 there. The reason we can't put a 7 there is it says that 2 are in the choir and the band. If I put a 7 there, that's going to make 9 people. We've only got 7 in the choir, so we pop a 2 there. 5 in the band, so 2 plus 3 is 5. Now altogether, how many students is that? That's only 10. So there must be another 20 students there. Now that we've got that, we can use that to find out the probability that the student is not in the band. Well, we've got 5 students in the band, and we've got 20 plus 5, making 25 out of 30 that are not in the band. So the probability is 25 out of 30. Part B, the student in the choir, the student is not in the choir or the band. So it's not there, it's not there, it's not there. That student must be one of those 20. So it's 20 out of 30. Or we could say 2/3, as we could say 5/6 there. Okay, here comes another. Right, so here's a whole load of information. There's a lot more information because we've got 3 things. We haven't just got 2 different parts we can have. We've got dogs, cats and fish. Now don't worry, you can't have 4 things with a Venn diagram. Try and draw one with 4 loops, it just don't work. But you can do one with 3. So pause the video, take your time and see what you get to. Now I don't know if you're more of a cat person, a dog person or a fish person, so I don't know which one you put at the top. I went with cats. Right, so 25 we've got dogs, we can't put that in. 53 own cats, can't put that in. Oh, it must be somewhere in the middle. Ah, right. 7 own dogs, cats and fish. That's definitely the first thing to put in. And I've got 100 altogether. So I'm going to sort of take them off as I go. I've got 93 left. Right. 11 own dogs and fish. So 7 plus 4 makes 11 owning both of those. 10 own cats and fish. Well, I've got 7 there, so 7 plus 3 makes 10 with cats and fish. 15 own cats and dogs, so 7 at 8 makes 15. I was going to take these off as I went, wasn't I? Oh well, take off 3 gets me to 94, gets me to 86. 8 gets me to 78. 25 we've got dogs altogether. I've got 15 there, 19 plus another 6 gets me down to 72. 40 own fish, that's a lot of fish owners. 11 plus 3 is 15. So, no, it's not. 11 plus 3 is 14. 14 plus 26 is 40, so we must have 26 there. So take another 26 off, and that is going to be 46. 53 own cats, lots and lots of cat owners. I think there's probably more dogs, I'm sure there would be really. 15, 18. 18 away from 53 is 35. So we need to take another 35 off there, which leaves us with 11 doesn't own dogs, cats or fish. Oh, so we can put that one in here. That's 11 out of 100. If you want to do 11%, that's fine too. Own dogs only, that's nice, that's that 6 there, so that's 6 out of 100, or 6%, or 3/50ths if you prefer, or 0.06. Doesn't own fish. Well, that's quite a lot of fish owners, weren't there? Well, we actually know that 40 own fish from there, so it's the other 60, isn't it? So that is 60 out of 100, which is 60%. Okay, we've got 3 more sort of exam style questions for you to have a go at. Now, it might not be essential to draw a Venn diagram to do a question like this. You could quite possibly do it without, but it's good practice to have a go. So pause the video now and do that. Now, this is a deceptively tricky problem at first sight. In the formula booklet, it actually gives you this thing. It says that the probability of A union B, this is on page 7 of the A-level formula booklet, is the probability of A plus the probability of B, which is what we're told, take away the probability of A intersection B. So all that's saying really is if you've got these 3 values here, they all add up to make that, don't they? If you add together that one, all of H and all of D, you will have added this bit in twice, so you have to take one of it away to make it equal to that. So we're going to use that idea, but what we want to know here, they've actually told us the probability of union is 0.7. They've told us the probability of H is 0.6. The probability of D, Decor magazine, is 0.4. Take away, that's the probability that we want, the probability of both. Now we could just do a little bit of reorganizing here. If I add the probability over to this side, the probability of A union B, add those together gives me 1, and then take that away over to this side, it gives me 0.3. And now that I've got 0.3 there, well, that is the probability of both magazines. I can fill in the rest. I know that Decor is probability of 0.4, so 0.3 plus 0.1 is 0.4. 0.3 plus 0.3 is 0.6. Must also be 0.3 over there. So higher magazine only will also be 0.3. Here's your next exam style question. Pause the video, give it a go. This is actually a far simpler one, because all they've done is they've told us the probability of point of B is 0.45. So that's all of these probabilities here. So we've got X plus 0.1 plus 0.2 is equal to 0.45. Well, if that's true, they add up to 0.3, take that away from 0.45, and X must be equal to 0.15. So then we stick that in there, and all the probabilities in the universal set have to add up to 1. So if you add 0.35 to 0.15 to 0.1 to 0.2 to 0.05, use your calculator, gets you to 0.85. So then the probability of y is 1, take away the probability you don't have y, which is 0.85, and that gives you 0.15 equaling y as well. Okay, one more problem for today, folks, coming up. And here it is, so give it a go. Right, so whenever they tell you that something equals something, that's an opportunity to make an equation. So the probability of m is 0.32 plus p, and that's equal to the probability of p, which is p plus q plus 0.07, all the probabilities in the loop. Now, I could take p from both sides, and it disappears. So what we've then left with is this. So if I take 0.07 from 0.32, I'm left with q on its own. So that must be 0.25. Now that I know that, the p's disappeared, so what do? Well, we go back over here. We can write in that that's 0.25, and all the probabilities in the Venn diagram have to add to 1. So we do 0.32, add 0.25, add 0.07, add 0.13, add 0.1. They all come to 0.87, and q is going to equal 1. Take that, because 0.87, not q, sorry, p is what's left, isn't it? So take that away, gives you 0.13 for p. And that's all for this week, folks. See you next time.